Yo, 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 what's good? What up, Hug? So right now, let me, it's cool. So right now, I'm about to look at this video real quick. I just need a quick update. So I got no grade for this motherfucker? That's weird. That's really weird. Hold on. So we're gonna start it. We can start now.
Let's start with this problem. Find the mean, median, mode, and range of the following dataset. Now, the first thing that I would recommend doing is arranging the numbers in increasing order. So the lowest number is 7, and we have two of them. After that, the next number is 10, and then 14, 15, 23, and 32. Now, to calculate the mean, what we need to do is we need to take the sum of the sum of the numbers.
Hold on, wait a minute. Hold on, bro. Course menu. Okay. Okay. I'm just doing this. I'm doing this at the same time. So it's like, yeah, I turned it in at the right time. What the fuck? Whatever. So right now I'm sitting at like a B plus in statistics right now. So I need to bring that up to at least an A minus, bro. I'm tired of being a B student for a little bit, but we'll see. I just want to keep it up as long as I can. So
And divide it by the 7 numbers that are in the data set. So this is going to be 7 plus 7 plus 10 and so forth. And then we're going to divide it by the 7
appreciate it,
numbers.
Pug. Let me know, Pug, if you're
So the
watching
mean is
this, bro.
basically the average
I know this is gonna be
of those
boring for
numbers.
you, but you're a smart guy. Hold on. So it's one, two, three, four, five, six, seven. So what is he finding the median on this bitch? It's coming back, I remember.
So
You
the
don't
total
remember,
sum that I
Pug.
got is 108. If you take 108 and divide it by 7, that's going to give you 15.4. I'm going to round it to 3. So it's approximately 15.43.
So that's the median, right?
So that is the mean. That's how you
Oh,
can
the
find the mean.
mean. Okay, okay, okay.
Now, what about the next thing? How can we find the median of this data set? The median is basically the middle number. So what I like to do is eliminate the first and the last number. And then working
Okay.
towards the middle, I'm going to eliminate the next two numbers until I'm left with the middle number. So as we could see in this example, the median is equal to 14. It's simply the middle
Okay,
number of the
okay. I
data
got
set.
that mixed up. Okay.
Now what about the mode? What is the mode in this problem? The mode is simply the number that occurs the most frequently. I think I
Damn.
said that wrong. It's
So it's
basically the,
seven.
the most frequent number in the data set.
Thank you, Big White. Thank you, Big White,
And
bro.
notice that
I'm
7
I'm doing statistics.
appears
I'm
twice
sorry. It's
in
gonna
this
be
data
boring.
set. So 7 is the mode.
What the fuck?
Now what about the range? The range
No
is
problem,
simply the
sir. Thank you, Big
difference
White. You the
between
man, bro.
the highest number and the lowest number. So it's going to be 32 minus 7, which is 25. And so now you know how to find the mean, median, mode, and range of a data set.
Damn, that shit was easy.
Now
Wow.
let's move on to number 2. Now this is going to
Wow.
be a similar problem, but it's not exactly the same. As you can see, we have 8 numbers in our data set as opposed to the 7 that we had previously. So let's begin by putting these numbers in order. So the lowest number is 11, and then the next number is 15, and then we have 21, and then 37, 41, and 59. So let's begin by calculating the mean. So the mean, represented by the symbol x bar, is equal to the sum divided by the number of numbers in the dataset. So let's add up the 8 numbers.
Okay, I already know that. That's fine. So what else is he talking about? Maybe I should just wait, but it's like, dude, you just explained that shit.
The mode and range of a dataset. Now let's talk about finding the quartiles and the interquartile range. So what I'm going to do right now is I'm going to make basically a number line with a beginning and an end. And let's say this number line represents our data. The lowest value is known as the minimum. The highest value in our data set is the maximum.
Okay.
Now we're going to break this number line into 4 equal parts. The first part is known as Q1. This is the first quartile. The second one is Q2, the second quartile, and then this is the third quartile. So let's say if the data was normally distributed, this would be at a 0% level, this would be 25, 50.
Well, I wish you guys could see me right fucking now. I got two fucking computers going at the same time. I'm learning this shit with. Damn, I wish you guys could see this. I got another computer right here. Uh, I'm gonna have to use my other goddamn. Damn, I'm gonna have to use my other fucking mouse. I'm gonna do my shit. This is what I do. I do my homework while I learn. I'm like, okay, while it's fresh in my mind, now's the time to do it. You feel me? You feel me? Damn. Hold on. You know? All right, let's keep going. I'm sorry.
75, and then this will be 100. So you could see how the quartiles are related to each other respectively.
Yeah, you just broke
Now,
them
how
up
do we
into
go about
quarters.
finding Q1, Q2, and Q3? How do we do that? Q2 is basically the median of the entire data set. Q1 is the median of the lower half of the data set. And Q3 is the median of the upper half of the data set. Now, the interquartile range, represented by IQR, this is the difference between Q3 and Q1. So once you find Q1 and Q3, you can now calculate the interquartile range. Now, the next thing that I want to mention is the ability to find or identify if a number in a dataset is an outlier. So here's what you need to know. It's not going to be an outlier if it's within this range. If it's between Q1 minus 1.5 times the IQR, so that's the lowest that it can be, or the highest it can be is Q3 plus 1.5 times the IQR.
Hmm.
So if you have a number that is within this range, it is not an outlier. But if you have a number in the data set that
Outside
is
of the range.
outside of this range,
Okay, okay, okay.
then that number is an outlier. So let's work on
Shit.
an example. Let's say we have the numbers 7, 11, 14, 5, 8, 27, 16, 10, 13, 17, and 16. Go ahead and identify Q1, Q2, and Q3. Calculate the interquartile range, the IQR, and determine if there's any outliers in this data set. Feel free to pause the video and use what you know to try it. Now,
Hold
as
on, I'm
always, the
sorry.
first thing we should do is
I'm gonna listen to him again. What was the question?
go ahead and identify Q1, Q2, and Q3. Calculate the interquartile range, the IQR, and determine if there's any outliers in this
Damn, fuck. Uh, I was kind of paying attention. I'm gonna see what he
data
does.
set. Feel free to pause the video and
I'm doing
use
the
what you
homework at the
know
same time.
to try it. Now, as always, the first thing we should do is organize the data. The lowest number is 5, and then we have 7, 8, 10, 11. Perhaps it's best if we cross it off as we go along. And then the next number is 13, and then 14, 16. There's two 16s, and then the 17, and then 27. Now, what do you think is our next step in order to find the interquartile range and the three quartiles? What's our next step? The best thing to do at this point is to determine the median of the entire data set, which is going to be Q2. So we could eliminate the first two numbers, the first and the last number, and then the next two until we get a number in the middle. So notice that 13 is
Mm.
in the middle. So therefore 13 is going to be Q2. Now what
Damn.
I like to do is I'm going to get rid of this number for now. And I'm going to put a line between the left side and the right side. So I want to separate the lower half of the data set with the upper half of the data set. But the 13 is still here though, so just keep that in mind. So that's our Q2 value. Now, Q1 is the median of the lower half of the data set. So what is the median of those five numbers? The median is
It's
simply going
8.
to be the middle number of those five numbers.
Yeah, okay.
So
So it's
Q1
Q1.
is 8. Now,
Damn.
what is the median of the upper half of the data set?
16.
Notice that the middle number is 16. So that is Q3. Notice that we have a total of 11 data points. And so that's why 13 is not included in the lower half or the upper half. Because if it was, one side will have 5 numbers, the other side will have 6. And that's why I
Mm.
chose to write it up here, so that the lower half is the same as the upper half. They both contain 5 numbers. Now let's go ahead and calculate the interquartile range, IQR. So we said it's the difference between the third quartile and the first quartile. So it's going to be 16 minus 8, which is
Which is 8.
8.
Damn, I
And so
was
that's
trying
how
to
you
get it
could
before he
find
said it.
the interquartile range of a data set. Now, what about the presence of any outliers? So looking at these numbers, do you think we have a number that really stands out that doesn't belong?
Looking at these numbers, yeah, 27. 27 don't belong.
Right now, 27 appears to be very far off from all the other numbers. So do you think 27 is an outlier?
Yeah,
Well, let's find
for
out.
sure.
So let's write down what we know. The presence of an outlier is based upon this range. It's Q1 minus 1.5 times the IQR to Q3 plus 1.5 times the IQR. So we know that Q1 is 8, and the interquartile range is also 8. Q3 is 16. So this is going to be 16 plus 1.5 times 8. What is 1.5 times 8? 1 times 8 is 8, 0.5 times 8 is 4, 8 plus 4 is 12. So this is going to be 8 minus 12, and this is 16 plus 12. Now 8 minus 12 is negative 4, and 16 plus 12 is 28. So now looking at what we have, is 27 an outlier based on this range?
Nah.
Because 27 is between negative 4 and 28, 27 is not an outlier. Now, if we
Damn.
had 29, that would be an outlier. So now
If
you
we
know
had
how to
-5,
determine
that'd be an outlier.
if a point is an outlier within a range. Now, let's talk
Interesting.
about how we can create a box and whisker plot.
Hold on. Brought to you by Mountain Dew, um, Dragon Fruit. Let's keep going.
The reason why we want to talk about this now is because it's related to the values of Q1, Q2, and Q3. So typically, a box and whisker plot looks something like this.
That's really good.
Assuming
That's
if
really
there's
good.
no outliers, this is going to be the lowest value. On the right, we're going to have the highest value, or the maximum. And then this line here represents the value of the first quartile, which is the 25th percentile. In the middle, we have Q2, the second quartile, which is the 50th percentile. And then this is Q3, the 75th percentile. And so that's the basic shape of a box and whisker plot. Now, what about if we have an outlier? Let's say if we have one to the right. Then this will no longer be the maximum. The outlier is shown as a point. It's outside of the box and whisker plot.
So the
Now, if
outlier will
it's
be
on the
the
left side,
maximum.
this will no longer be the minimum, and that will be the outlier there. So let's work on
Damn.
an example. Let's say we have the numbers 16, 18, 28, 13, 50, 31, 25, 22, and let's say another 18, 23, 29, 31, and 38. Actually, I wrote down 31 already. Let's make this 38. So we have 12 numbers. Using this data set, go ahead and find the interquartile range, Q1, Q2, Q3, identify the presence of any outliers, and then using all of that information, construct a box and whisker plot. Feel free to pause the video if you want to try that yourself. Now the first step, as always, is to write the numbers in increasing order. So we have 13, 16, 18. So let's get rid of those numbers. And then there's another 18, and then 22, 23. Next is 25, and then 28, 29. And then the last three are 31, 38, and 50. Now, what I like to do is break up the data into 4 quarters, or 4 sections. Now, because we have an even number of data points, we have a total of 12, we can put a line right in the middle. So now this is the lower half of the data set, and here we have the upper half. So let's determine the median for the entire data set. Because it's even, we can't just immediately identify the median. The median is going to be an average of these two numbers. If we
Mm.
eliminate the first two, and then the next two, and so forth, we will eventually get to these two numbers. So
Mm.
what is the median between, or what is the average between 23 and 25? So if you add up those two numbers and divide by 2, you're just going to get the midpoint of 23 and 25, which is 24. So 24 is
So you would write it
the
up there, or
second
okay,
quartile.
on the bottom
This is the Q2 value. Now let's
automatically.
focus on the lower half of the data. What is the median of the lower half of the data? So notice that we have 6
It would have to be
data points in
between
that
18
section.
and 18. So 18 plus
And
18
because it's even,
divided by 2.
the median is going to be an average of these two numbers.
Okay.
So let's put a line there. The average of 18 and 18 is 18. So that's our Q1 value.
Damn.
Now what about the median of the upper half of the data? So because we have 6 numbers here, we're going to put a line right in the middle. So we have 3 on the left, 3 on the right. And the median is simply going to be the average of these two numbers. The average of 29 and 31 is the number in the middle, which is 30. And so this is why I like
Wait a
to
minute.
use
Wait a
these
minute.
lines
Wait a
here.
minute. Wait a minute. Wait a minute.
So now we
Hold on.
have the median is
Is he just taking the number in between 29 and 31?
simply going to be the average of these two numbers. The average of 29 and 31 is the number in the middle, which is 30. And
Damn. Did he
so
just do
this
quick
is why I
math?
like to use these lines here.
Okay.
So now we have 3 numbers in each of the 4 sections of our data. So now that we know Q1, Q2, and Q3, what is the interquartile range? What's our IQR value? The IQR is the difference between the third quartile and the first quartile. So it's going to be 30 minus 18, which is 12 in this example. So now that we have that, our next step is to determine if we have any outliers in this problem.
Hmm.
So remember, this is what we need. We need to create a range. The lowest point of it will be
Minus
Q1
1.5
minus 1.5 times the IQR, and the highest
IQR
point of the range will be Q3
minus
plus
the plus the IQR.
1.5 times the IQR.
Okay.
Now I'm going to have to get rid of a few things. So let's write down the information that is important. So Q1 is 18, Q2 is 24, Q3 is 30. Our minimum, the lowest value is 13, and the maximum, our highest
50.
value is 50. So let's keep that in mind. So now I can get rid of this. You may want to write that down just in case we need to go back to it. And I
Mm.
can also get rid of this too. So let's plug in what we know into this expression. So Q1 is 18, and the IQR, I got to write that down again. That was 12. It was 30 minus 18, which is 12. So this is going to be 18 minus 1.5 times 12. And then Q3 is 30 plus 1.5 times 12. Now what is 1.5 times 12? So it's basically 12 plus half of 12, which is 6. 12 plus 6 is 18. 18 minus 18 is 0. 30 plus 18 is 48. So do we have any outliers? are there any numbers outside of this range? And it turns out that there is. The maximum 50 is not between 0 and 48. So this is an outlier. Now going back to our original data, I'm just going to rewrite it so you could see everything. This is what we had.
So how can it
So
be an
now at this
outlier
point,
if it's 48?
let's go ahead and let's make a number line. So 0 is going to be our lowest point, and we're going to go up to 50. So let's go by tens. And let's put a mark in the middle to represent the fives. So let's begin by drawing a box. So we need to draw a box ranging from Q1 to Q3. So that's going to start at 18. And this is basically a rough estimate. It's not going to be perfect. And the end of the box will be at 30. Now, 13 is the minimum, which
Mm.
is approximately around that area. So that's the left side of the box. And 50 is the maximum, but that's an outlier. So we're going to just put a point at 50.
Ah.
38 is the second highest, which is not an outlier. So that's going to be part of the box and whisker plot. And so 38 is in this region. So we're going to say it's over there.
Mm.
Now, Q1 is 18, Q3 is 30, but we also need to write where not Q4, but where Q2 is. Q2 is 24, which is
That'll
around
be the middle.
here.
Yeah.
So this is Q1, that's 18, Q2, and Q3. So the length of the box represents the interquartile range, which is 12. That's 30 minus 18. And so here is the minimum, and this is the maximum, which is the outlier. But that's how you can construct a box and whisker plot given a data set. Now the next topic we need to talk about is skewness. So let's say we have this representation of our data. And notice that it is symmetrical. This line represents the median. And if you have a data that is perfectly symmetrical, the mean, this is the sample mean, it's going to be equal to the median. Now, the box and whisker plot will look something like this. Q2 is going to be right in the middle of Q1 and Q3. So notice that the box plot is evenly distributed. The left side is the same as the right side in length. And also, these lines are equal in length. So that represents a symmetric distribution. Now, what if it's not symmetrically distributed? What's going to happen in that case? There are two possibilities. The data can be skewed to the right, or it can be skewed to the left. So which one would you say this particular shape represents? Would you say it's skewed to the right or skewed to the left? Notice that
Skew
we
to the right.
have a tail that extends towards the right. So this particular data, or this graph, we say that it's skewed to the right. Now, what is the relationship between the sample mean and the median in this case? So the median, the middle portion of the data, will be somewhere in this region, and the sample mean will be to the right of the median, since it's skewed to the right. So the mean will be greater than the median in this case.
Mm.
By the way, whenever you have a shape that's skewed to the right, Some textbooks will refer this as a positive skew. And it makes sense because positive numbers on a number line will be on the right side. Now, you need to be familiar with the box and whisker plots for this type of distribution. So here's one example. Notice that the right side of the box is longer than the left side. So this tells us that Q3 minus Q2 is greater than Q2 minus Q1. And so in that case, looking at the box and whisker plot, you can see that it's skewed to the right. Now sometimes these two boxes may be equal in length. Nevertheless, this side might be longer than this side. So even if the boxes are of the same length, if this side is longer, it will also be skewed to the right.
Hmm.
Now, what about if it's skewed to the left? In this case, the graph is going to look something like this. Let me try that again. So notice that the tail is on the left side. So in this case, we have a negative skew, or we could say that is skewed to the left.
Hmm.
Now the
Damn, he
median
does make this shit
will
easier.
be somewhere in this region, and the mean is going to be to the left of the
Hmm.
median, since it's skewed to the left. So the sample mean is less than the median. Now, how can we represent this using a box plot? Well, here's one possibility. So in this case, Q2 will be closer to Q3 in the box plot. So as you can see, the left side is longer than the right side. So we can say that Q2 minus Q1 is greater than Q3 minus Q2 in this case. Now, if the boxes are equal in length, you can also tell that we have a negative skew if the left side of the box plot is longer than the right side. So that's another indication that the data is skewed to the left. Now, there's some other things that you need to know if you're going to take a statistics course. And you need to be able to create a dot plot. So let's say if you have the numbers 5, 8, 3, 7, 1, 5, 3, 2, 3, 3, 8, 5. With this information, how can we construct a dot plot? Well, we could begin by drawing a number line. So let's say this is 0, 1, 2, 3, 4, and so forth. We could stop at 8 since 8 is the highest number. Now the first number is a 5. So all we need to do is draw a dot above the number 5. And then let's put the dots one at a time.
Yo,
So
what
the
up,
next number
Cyberwolf?
is an
Good to see
8.
you. I'm just
So
doing
we're
my
going to draw a
statistics
dot at
class and
8.
I'm looking into it.
And then it's a 3. So let's put the dot there. Next we
7?
have a 7. And then it's a 1. And then a 5. So notice that we have a second 5. All we need to do is draw another dot above the first one. And then it's a 3, 2, and then another 3,
Another dot.
and another 1,
Another dot.
and then 8,
Okay.
and then 5.
Alright.
So that's how you can make a dot plot. Now using this dot plot, which number is the mode? What would you say? Now if you recall, the mode is the number in the dataset that occurs most frequently. So in this case, it's the number with the most dots. So the mode for this dataset is 3. By the way, if you haven't done so already, don't forget to subscribe to this channel and click on that notification bell. Now let's talk about how we can make a stem and leaf plot. So let's say we have the numbers 4, 9, 13, 13, 17, 21, 36, 38, let's say another 38, and then 56. How can we make a stem and leaf plot with this data? So the first thing we need to do is we need to write 2 columns. On the left is going to be the stem, and on the right, the leaf. So the first number is 4. So for the stem, we're going to write 0. And for the leaf, we're going to put 4. The next one is 9. So we're going to write or represent 9 as 0, 9. So we have 0 on the left, and then we're going to put 9 on the right. The next number is 13. So the first digit is a 1. The second digit we're going to put in the second column. Now
Oh
we have another
shit. Okay,
13.
I see.
So all we got to do is add another 3. Now for
Okay.
17,
You should just add a
we
7.
need 1 and 7. We already have the 1, but we need to write the 7 to the right side.
And then you start 2, and then it'll be 1.
Now for 21, we need to put a 2 in the stem column, a
Hmm.
1 in the leaf column. Next we have
Interesting.
36, so we need a 3 in the stem column, a 6 in the leaf column. Now notice that we have 3 38s, so we got to add 3 8s to the leaf column. And finally, 56. Now we don't have anything in the 40s, so we're going to write a 4, but we're not going to put anything here. For 56, we're going to write a 5 in the stem column and a 6 in the leaf column. And so that's how you can make a stem and leaf plot. Now it's always good to have a key. So we could say that 2, 1 represents 21. So if someone looks at the stem or leaf plot, they know what you mean. Let's try another example. So let's say we have the numbers 56. Actually, let's say 78, 85, 89, 92, 106, 107, and 119. Go ahead
Okay.
and make a stem and leaf plot with those numbers.
That's easy. I'll still put 0, 1, 2, 3, 4, 5, 6, and then
So
when
the
I get to
first number is
7,
78.
I'll be
We're going to
7
write
and
a
then.
7 in the first column and an
Oh,
8 in
okay.
the
So I
second
don't have
column.
to. I don't even have to
Next, we
put the
have
1, 2, 3.
85 and 89. So we're going to put an 8 for the first digit
All right. Well,
and
that
then
makes it
5 and
easy.
9 for the second. And then it's 92, so we're going to write 9 and 2. Now for 106, we're going to put a 10 in the stem column, but a 6 in the leaf column. And for 107, we just got to add a 7 here. And there's usually no commas, so let's get rid of that. And then finally, for 119, we're going to write 11 in the stem plot and 9 in the leaf column.
Hmm.
And so, for example, this will be our key. So this represents 92, and this would represent
106.
106.
Okay.
Because sometimes you could have decimal values. For instance, let's say if we have 1.2, 1.6, 1.8, 2.1, 2.3, 2.3, and 2.5.
Oh, let me guess. Let me guess. If we got 1.2, what would that look like? Wouldn't it just be a 1 on the stem and then on the leaf it would be point 0.2? Would it be point 0.2? Or like 0 point 0.2? I'm just guessing. I'm just guessing. Let me see.
We can construct this stem and leaf plot like this. So we could start with 1, and to write 1.2, we could just put a 2 for the leaf plot. Now for 1.6, we just got to put a 6 in the leaf column. And for 1.8, just an 8. Now we can move on to the 2's. So we have 2.1, 2.3, 2.3, and 2.5. And so that's how you can make a stem and leaf plot using decimal values. So we could say 1/6 represents 1.6 in this particular example. Now the next thing we're going to talk about is something called a frequency table. So given a data set, how
Hold
can we
on, I didn't even
make
look at that. I
a
heard it,
frequency
but I
table?
want to see it. Sorry.
Now for 1.6, we just got to put a 6 in the leaf column. And for 1.8, just an 8. Now we can move on to the 2's. So we have 2.1, 2.3, 2.3, and 2.5. And so that's how you can make a stem and leaf plot using decimal values. So we could say 1/6 represents
1.6.
1.6 in
Okay,
this
I
particular
guess not.
example.
Damn, I was off.
Now the next thing we're going to talk about is something called a frequency table. So given a data set, how can we make a frequency table? So let's say we have the numbers 5, 9, 8, 7, 8, 12, 9, 8, 10, 8, 9, 7. So using those numbers, how can we make a frequency table? We're going to put 2 columns. So the first column will represent the number, and the second column will represent the frequency. And let's put down what we have. So the first number is a 5. And how many 5s do we have? There's
One.
only one 5, so the frequency is 1. The next number is a 7. And notice that we have 2 7s, so
So
the
two.
frequency is 2. Next
Damn.
is 8. We have a total of 4 8s, so that gives us a frequency of 4. After that, we have 9, and I've spotted 3 9s, and then there's 1 10, and we have 1 12. So that's a simple way in which you can make a frequency table. Now, here's another question for you. How can we use the frequency table in order to calculate the sample mean? How can we calculate the average instead of just adding all of those numbers up and dividing by the number of data points in a set? Let's add another column, and we're going to call this the sum. Now, we have 1 5, so 5 times 1 is 5. We
Mm.
have 2 7s. If you add up 7 and 7, you get 14. We have 4 8s. 8 times 4 is 32. Or if you add 8 4 times, you get 32. 9 times 3 is 27. 10 times 1 is 10. 12 times 1 is 12. Now we're going to add up the sum column to get the total sum. So 5 plus 14 plus 32 plus 27 plus 10 plus 12, that's 100. And we're also going to add up the frequency column. That's going to give us the total number of numbers that we have here. So we have 1 plus 2, which is 3, plus 4, that's 7, plus 3, that's 10, plus 2, that's 12. So we have a total of 12 numbers. So the mean is going to be the sum divided by the total number of points that we have in our set. So it's 100 divided by 12. So the mean in this example is 8.3 repeated. And so that's how you could use the frequency table to calculate the mean of a data set. Now the next thing that you need to know how to do is how to create a histogram. A histogram looks like a bar graph, but Unlike a bar graph, a histogram has its bars connected to each other. So here's an example of a histogram on the left side. On the right side, I'm going to draw a bar graph. So this would be a bar graph. So as you can see, they're very similar, but the bars in a histogram, they're adjacent to each other. There's no space in between. But how do we go about taking a data set and making a histogram? So let's say we have the test scores of students in a typical class. Let's say the test scores are 65, 72, 93, 68, 76, 98, let's say 84, 85, 79, 88, 90, 82, 83, 87, and 78. Now the first thing we need to do is create a frequency distribution table. And so what we're going to do this time, rather than talk about how frequent, or rather than describing the frequency of each number, we're going to break it up into categories or classes. On the left side, we're going to have the grade. On the right side, the frequency. Now, I'm going to categorize the grades in levels of 10. So a D would be 60 to 69. A C would be 70 to 79. A grade of a B would be 80 to 89. And an A is going to be 90 to 100. So those are our four categories or four classes. Now, how many students received a grade between 60 and 69? So notice that there are two students. We have the grades 65 and 68. So the frequency will be 2. Now, how many students received a C on their exam? How many students received a grade of somewhere between 70 and 79? So we have 1, 2, 3, and 4. So 4 students got a C on their exam. What about a B? So we have 84, 85, 88, 82, 83, 87. So I counted a total of 6. And what's left over are those who got an a 93, a 98, and a 90. So now that we have our frequency distribution table, we can now make a histogram. So on the y-axis, we're going to plot the frequency. On the x-axis, we're going to put the grades. So the grades will vary between 60, 70, 80, 90, and 100, because the classes are separated by intervals of 10, approximately. Now, the highest frequency is 6, so let's go by 1. 1, 2,
I'm gonna go on
3,
for another 10 minutes,
4,
guys.
5, 6. So let's plot the first one. Between 60 and 69, which is close to 70, the frequency is a 2. So it's going to look like that. And then between 70 and 79, 4 students got a grade in that region. I'm going to use the same color. And between 80 and 89, 6 students fall in that category. And between 90 and 100, only 3 students received an A. So let's put the grade. So this is a D. 2 students got a D. 4 students got a C. And 6 students received a B. And 3 students received an A. So that's how you can create a histogram from a data set like this using a frequency distribution table. Now, there's something else that we need to go over, and that is making a table with the frequency, the relative frequency, and also the cumulative relative frequency. So let's say we have the numbers 2, 3, 5, 3, 6, 8, 7, 8, 3, 3, 5, 3, 7, 3, 8, 5, 2, 7, 8, 3.
Shit, I'm
So
tweaking.
we're going to
Let
have
me look.
4 columns. The first column is going to be the value. The second column will be the frequency. The third column is going to be the relative frequency. And the last one is going to be the cumulative relative frequency. So the lowest value that we have in our list is 2. And notice that we have 2 2's. So the frequency for that number is 2. Next, we have a 3. And we have 1, 2, 3, 4, 5, 6, 7 3's. So that's the frequency. The next number in the list is 5. We have 1, 2, 3 5's. Now we only have 1 6, which is here. Next is a 7, and there's 1, 2, 3 7's. And I need to extend this list. And then finally we have some 8's. 1, 2, 3, 4 8's. Now let's take the sum of the frequency column. So if we add these numbers, 2 plus 7 is 9, plus 3
Damn,
that's
statistics really
12,
ain't that hard when you get
plus 1 is
explained.
13, plus 3 is 16, plus 4 is 20.
Hmm.
So we have a total of 20 numbers in our set. Now how do we calculate the relative frequency? So for the first entry in that column, take the frequency and divide it by the total number of numbers that you have in the data set. So the relative frequency is basically the frequency divided by n. So for the first one, it's going to be 2 over 20, which is 1 out of 10, and so that's 0.10. For this one, it's going to be 7 divided by 20, which is 0.35. And for the next one, it's 3 divided by 20, which is 0.15. And then it's 1 divided by 20, that's 0.05. 3 over 20 is 0.15 again, and then 4 out of 20 is 0.20. Now, if you add up all of these numbers, you should get 1. And next we have the cumulative relative frequency. So we're going to start with 0.10, and then we're going to add these two numbers. 0.10 plus 0.35 is 0.45. Now 0.45 plus 0.15, that's 0.60. And then if we add 0.60 and 0.05, that's going to be 0.65. And then add in those two numbers, that's going to give us 0.80. And then 0.80 plus 0.20 will give us 1. So that's how you can complete the cumulative relative frequency table given a data set. Now, let's talk about how we could use this information. Using this table, what is the value of the 60th percentile? What would you say? So what we need to do is look at the cumulative relative frequency. So the 60th percentile will end here. Now notice that it's exactly 0.60, which corresponds to 60%. To find the 60th percentile, you need to average these two values. So you have to do 5 plus 6 divided by 2. The average of 5 and 6 is 5.5. And so that's going to be the 60th percentile. Now what about the 80th percentile?
That'll be
So notice that we
4 and
have
8, right?
exactly 0.8 in the cumulative relative frequency column.
4 plus 8 divided by
So what
2?
we're going to do is we're going to average these two numbers. The average of 7 and 8 is 7.5. Now, what
Okay.
if it's not listed in
Oh,
the
okay, okay,
cumulative
okay, okay,
relative
okay.
frequency table?
I thought it was a
For
4.
instance, let's say if we have, or if we want to find the 20th percentile, what value
Hmm.
corresponds to that? Now, the 20th percentile is between 0.10 and 0.45. It's important to understand that after 0.10, you're going to exceed the value of 2. You're going to go into the 3s. And after 0.45, you're going to move from the 3s to the 5s. So the 20th percentile, because it's more than 2 but less than 3, it's going to be 3. There's no numbers in between here if you look at the data that we have. So the 20th percentile is going to fall in this number. To explain it better, it's important to understand that between 0 and 0.10, the value is 2. Between 0.10 and 0.45, the value is 3. Now, if your percentile falls between 0.45 and 0.60, not including 0.45 and 0.60, but if it's between those numbers, then it's going to be 5. It's going to be 6 if it's between 0.60 and 0.65. And it's going to be 7 if it's between 0.65 and zero point 0.8. So let's say if we want to determine the 75th percentile. The 75th percentile is between 0.65 and zero point 0.8. So because it's more than 0.65, we're not going to have the value 6. We're going to get 7. So that's going to be the 75th percentile. Now, let me help you to see this visually so that it makes more sense. Let's begin by arranging the numbers in increase in order. So we have two 2's. We have a total of 7 3's. And we have 3 5's, 1 6, 3 7's, and 4 8's. Now I'm writing these in pairs of 2's, and you'll see why. We have a total of 20 numbers, and if you take 20 and divide it by 2, you're going to get 10 equal parts. So this is going to be the 10th percentile. Let me put that in a different color. So here's the
Damn.
10th percentile, the 20th percentile, the 30th, and so forth. So this would be the 100th percentile. There's nothing higher than that. So the first thing that we went over was the 60th percentile, which is here. So notice that we have a 5 on the left and a 6 on the right. So we need to average 5 and 6. And so we said the
5.5.
60th percentile was 5.5.
Damn,
The
okay.
second one was the 80th percentile, which is here. Notice that it's between two different
7.5.
numbers, 7 and 8. So if we average 7 and 8, it will give us 7.5. Now after that, we talked about the 20th percentile, and the two numbers that it's between are identical to each other. So
So just be
therefore,
3.
the 20th percentile is just 3. And the
Yep.
last one was the 75th percentile, which is between 70 and 80. And so these two numbers are just 7. And
So
so the
7.
75th percentile has to be 7. So now you can visually see the values that correspond to the different percentiles. And if you want to, you could put 0 as well. I forgot to do that. But that's basically it for this video. So hopefully it gave you a good
Wow.
introduction into statistics. There's a lot of other stuff that you'll learn in this course, but these are
Wow.
just some of the basics. Thanks again for watching.
Hey, thank you guys for coming through and coming through and looking at that. I mean, it's kind of hot up in here. Whoa. But hell yeah, I appreciate you guys coming through. Y'all let me know Y'all let me know what's going on. This was actually really good. Really, that wasn't even that hard to really understand. But all right, y'all. I'll see y'all later, man. Hey, remember, we still got the donation goal. If we can still reach, if we can still reach, whoa, if we can still reach this goal right down here, that'd be great. Let me know. I'm always down. All right, we're good. We're good. My bad. I had to check that out. But I'm gonna get going. Y'all let me know. Peace. Stay tuned.